Good afternoon, GrrCON. You guys are still awake? Everybody's worked off the hangovers by now? Hopefully? Perfect. There are extra credit points for bringing beer, especially when you bring one for the speaker, but no one's done that yet, so that's all right. So welcome to What's in Your Top 10, Intelligent AppSec Prioritization. My name's Tony Miller. If you guys have seen me speak before, this is going to be a little uncomfortable for me. I'm not used to being tied to a podium. If you've seen me before, you know that usually I'm all over the map, but hey, we'll make things work. So this is who I am. I'm a principal security engineer. I lead the program services practice at Aspect Security. I mention their names because they were the folks kind enough to sponsor my time and my expenses to be here. They also do this really cool thing of depositing, unsolicited amounts of money in my account every, half of a month or so. Who I am, I spent 11 years in application security. Prior to that, I spent an additional 9 years as a software developer in some large financial institutions and so forth, all sorts of fun stuff. You've got my Twitter handle there. I will give you fair warning. If you decide to follow me, I will probably be one of your more boring follows on Twitter. But go ahead, add me anyway. I'll follow you back. You've also got my email address up there. If after the talk you've got questions or you want to chat some more or you just want to tell me, man, you suck. Hey, I'm here for you. I'll listen up. So what are we going to talk about today? Oh, see, now here's a man with a plan. We've got beer. We're rocking and rolling. Round of applause for this cat. All right, so far so good. So what we're going to talk about today, this nebulous thing I put out there, I said I was going to tell you all about intelligent application security prioritization. Well, what in the world does that mean, right? So we're going to talk a lot about threat modeling and how we use that to plan out our security spend and really focus where we're going to put security efforts within our organizations. I know it's late on the second day, but I need a little participation here. How many of you guys out there work for, say, a decent-sized organizations? Maybe you've got 100, 200, 500 systems you're responsible for? Okay. Pretty unwieldy when someone says, hey, you got to test all that stuff every so often, blah, 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 right? How are we going to test 500 things every year or something like that? So we're going to talk a little bit about strategy, how we do that, and we'll use some threat modeling and some risk analysis to do that. And I'm going to hopefully show you how to make it real simple. So I'm going to talk about why we should be or why we do threat model, for those of us that do. Any of you out there have threat modeling as part of your security programs today? 1. 2. All right. So, and that's not a bad thing. I mean, that's not uncommon. Threat modeling is one of those things we've been talking about for a long time, but it doesn't really happen all that often. So we're going to talk about why we don't do it. We'll also get into some idealism of threat modeling versus the reality of threat modeling. And we're going to talk about this whole idea. How do we ensure all is not lost? You'll see what I mean when we get there. And then, of course, let's make it simple, right? So keep it simple, stupid. So why do we threat model? Anybody read Adam Shostak's book? It's a pretty good book. The same one guy who does threat modeling is the one person who read the book. If you're interested in threat modeling, I strongly recommend that book. It's 500 some pages. You actually don't need to read it all at once. The first half is really good to tell you how to do threat modeling. The second half is all reference for when you're doing threat modeling. Good book. I say that now because I am going to probably beat up on him a little bit, not Adam personally, but the book there's nothing wrong with the book, but there are some things I think we can do a little better. Why do we do it? First of all, it's a way for us to push security early into the SDLC, right? We hear this all the time. We hear people talk about, hey, we got to do more things early on in the development life cycle. We got to put more security there. We got to design security into our applications. Well, how do we do that? Threat modeling is one way that we can start to do that. Threat modeling allows us to recognize issues in how we're designing our apps. The ideal threat model that we'll talk about in a little bit allows you to proactively say, hey, if you're going to build an application that does this, you need these controls to make sure you're going to keep that application secure before you ever start developing anything. That's pretty cool, okay? Another thing that threat modeling does for us is it brings that business context to our security structure. So if we're going to talk about building security into an application, we really want to understand what that application does proactively instead of the typical pen test. We get handed an app. Okay, maybe we find out some information about what it does. Maybe we discover some information about what it does just by doing some reconnaissance. This gets us a little more intelligence from the business side, which can be very effective when we start talking about what kind of security controls do we need. And then finally, we understand, if we're talking in a large organization now, how does that application contribute to our overall security posture within the organization? So that's why we want to be doing threat modeling. That's what threat modeling was intended to provide us with. But now let's talk about why don't we? There's a good book out there called Juggling Elephants. It's one of those high-level management books that I don't normally read, but this one I actually kind of like. The reality is, for those of us, especially those of you that said, hey, I've got 500 systems I'm responsible for, we are juggling elephants. Everything's a priority. We've got all of these systems. Each one of them in the owner's mind is a critical priority to the company. In addition, just within the security space, we've got all these conflicting things that we're told we need to do, all these security activities that we're supposed to be doing. We're supposed to be doing pen tests. We're supposed to be doing code reviews. People are telling us we're supposed to be doing our scans. All this stuff. We need firewalls. We need WAFs. We need this. We need that. All these elephants up in the air. How do we pick the ones that are most important? If we drop any of them, they land on our head. We're done. So that becomes a major issue now when we start talking about threat modeling, because now threat modeling becomes yet another baby elephant that we want to throw up there and give our security folks and our development teams to juggle. Another problem with threat modeling is, what is it really? Most people don't really have a clear understanding of what threat modeling is. In addition, if you go out and you try to research what is threat modeling, aside from, again, the ShowStack book, which has kind of become like the Bible for threat modeling, there's about 1,000 other resources you're going to find, and not one of them agrees with the other. What is threat modeling? Okay, it means something to each individual person. Go out there and look at service companies like my own, consulting companies that offer this as a service, and what you're going to see is everybody talks about it a little bit differently. Everybody offers their own flavor of it. So what that means now is if I've got an organization who says, hey, you know what, I want to push SDLC security, I want to get this threat modeling thing that I've heard all about into my SDLC because I've been told that that's an easy way for me to push all the security farther into the SDLC. The cost of entry is just astronomical, because just trying to figure out what you're going to do leaves you searching and searching and searching. So it's time to come up with your own methodology. And are you going to do it right? Are you going to do it wrong? What is right? And as we're going to see, what's right isn't always the same for each organization. And then finally, the reason why organizations don't do threat modeling today, because we as security folks don't do a good job of establishing why it's important. We talk about this nebulous idea of, hey, we're going to push security over here left in the software development lifecycle. There's one of those cliches for you. We want to push everything left. Well, okay, great. I can kind of see as a manager why that's important. But you know what? I've got all this tactical stuff I've got to worry about. I've got people trying to attack me every day. I'm worried about getting firewalls and keeping them running. I'm worried about putting web application firewalls in front of my apps. I'm worried about my SIM and what's it telling me and how do I react to it. All these things. I'm already spending maybe millions of dollars on penetration testing and so forth. Now you're telling me we need yet another security activity. Why? So we throw this out there as, hey, threat modeling is this great, wonderful thing, but we don't really put any context around it. So what we need to do as security folks is first understand the value of threat modeling ourselves and how we can drive that value within our organizations. And then we need to be able to communicate that and really display that to our management so they understand better. So hopefully some of the tools I'm going to give you during this talk today are going to help you with that. We'll talk about, as we get into this now, some of the ways that we enable better share of information between information security and developers, how that saves us money then in the long run in development, and we'll get more into that as we go along. So, For the one person who read Adam's book, and for the rest of you who haven't, let's talk a little bit about the ideal threat modeling. So this is really according to what Shostak talks about in that book, and this is also what you'll find most people kind of get as a general concept. The ideal threat modeling happens during the concept phase of any application lifecycle. So if we're building a new application or we're thinking of bringing something in from a third party, whatever it is, we do threat modeling at the point that, hey, we need this system to do X, Y, Z. We're not designing it yet. We're not doing anything. The intent is we kind of talk about what is this system going to do? What kind of data is it going to house? What other systems is it going to talk to? And then we think about, well, who wants to attack that system? So, and then from there we can say, okay, based on this, you need to make sure that when you build this system, so as you're designing it, put in these controls that are going to address those threats, those actors who would come after us to do us harm in all these various different ways. The problem with this, any DevOps developers out there? Anybody doing continuous integration? There we go, we got a couple. Concept phase isn't really much of a phase, is it? It's, hey, I got an idea, let's write it. There's no time to sit down and stop the development process for something like this. Even if you're in a traditional waterfall or agile shop, oftentimes things go straight from concept into design in a heartbeat. When we do this, another issue with trying to do threat modeling that early is we've got no design context at all. So yeah, it's great. We throw threat modeling out there. We do it nice and early. Hey, we're going to be really proactive. We're going to figure out what the threats to this system are before we do any coding. And then they can design it and they can make sure it's all secure. It sounds great in theory. And I see you're shaking your head already, and I think you're probably on the same boat I am, maybe. The problem is without design context, there are design features that implement new threat or introduce new threats. So if I'm not considering what that design is going to be, there are potentially threats that go unnoticed. The intent is that we do a lot of this threat modeling, which includes building, some data flow diagrams and all these wonderful things, understanding where this data is going to flow and who's going to attack it. And then we're supposed to go back and validate that later. We're supposed to do other activities that we're not doing today to go back and validate that, hey, all these things that we said during our threat model are true and correct and accurate. So now you're talking about a security activity that lives on through the entire life cycle. If you're Microsoft and you have the ability to do that kind of thing and you're huge and you're writing software that's going to be used by millions, yes, you probably have the time and the effort and the money to spend to do that. The reality is for most of us, that's not something that's going to float if we try to sell that to our management. In the end, if you get threat modeling going according to this ideal program, what you end up with is what we in security think is great, right? Security drives the architecture we're going to use, the technology that we're going to use, and it drives the design of our applications. Sounds good, right? How many of you work in any organization where that actually happens? One. Do you work for Microsoft? Okay, I bring that up. Microsoft is very good at this, and it works for them. The problem is, for most of us, that ideal never occurs, right? Info security does not get the opportunity to dictate design. New technologies come up all the time that are driven to be used within our organizations because they offer some new functionality or something new and sexy that somebody wants to add, and we are stuck, from a security perspective, having to react to it. So the reality is, we don't usually see that ideal. The timing was perfect on that. My friend Stephen A. Smith, hey, let's be real here, okay? Let's talk about what the reality is. What if we take a more pragmatic approach to this and realize, first of all, we're probably not going to have much of a concept phase where we can really slow development down. If we're in a DevOps or continuous integration environment, it's just not going to happen. Even if we're in Agile, Yeah, we're writing those stories, we're putting them out there. Maybe we're going to have a chance to do this. But what if we push something a little bit later? What if we make threat modeling a part of our design phase for some of those more traditional methodologies, or even into coding if we're talking about, continuous integration or so forth, or even, God forbid, I know this is, a horrible thing to say, but even maybe after post-production, right? So we've got a continuous integration environment, we put something in the way of code in. That's part of continuous integration, but we still want to go back and look at that, right? And maybe there's something that threat modeling can provide us that our traditional pen testing doesn't, and we'll look at what that is. By doing this, what we're able to do, as I said before, is we can leverage that design context. So now we've got an established design at minimum, or we're working with our developers as they're going through that design, and maybe we're talking to them about some of their design ideas. What are some of the things they want to do? What are some of the things that they're planning? Some of the technologies that they want to implement? Are they doing single sign-on? What type of provider are they using? Things of this nature. We want to understand those and the threats that they are going to potentially introduce. So what you get now is you get security requirements that are being derived from that architecture, from that technology, and from that design. And we'll see how this feedback loop is going to get set up, and it's going to start to drive us toward maybe getting to that ideal state where now we can do this. We can establish security earlier than the design phase. Finally, if we're able to do this, this becomes something that's repeatable when we have redesigns. Oftentimes, I've seen organizations, there are not many out there that do it, but there are some who do have an early threat model methodology. They do it once when they create a new application and it's gone. That's all they do. By pushing it a little later into design phase, now if I know I've got a major rewrite or we're going to replace an application with something else, now I've got a repeatable process that I can use that fits into those spaces as well. So let's delve a little bit deeper, and I promise these are going to get less textual and a little easier to read as we go. But let's talk about what we're looking at when we do this architecture design. First of all, by doing this threat modeling as part of the architecture and design, we are able to identify design patterns. What are the common things that we're doing? If we're implementing single sign-on, that's a design pattern, hopefully. Hopefully there's a standard way that we do single sign-on, or we can start to define one. Do we have specific providers that we use? Are we a SiteMinder shop and we're going to always implement SiteMinder? Or do we have specific implementations for things like OAuth? Those types of things we can pull in as specific design patterns. We identify them, and we can start to use our threat modeling to not only pull those out, but later on, as we'll see, we can use the threat modeling to actually enhance those design patterns. When we start to identify these patterns, we can also start to refine our threat models and make the threat modeling better by linking those common threats that we know are part of this particular design pattern back to that pattern. Now when we see that pattern in our threat model, hey, we're able to call that out. We may have specific strategies and specific design guidance, as we'll see, that goes along with that. Because we have a design, hopefully we have some concept of where security controls are. So as I start to identify threats, I'm also able to look at some of the security controls that we're planning to implement and not only determine if I have them, but how about their relative strength and their type. Those are things that are going to be important that help me better define maybe changes that are needed or improvements that are needed within that application design. And then finally, as I said, this design or this activity drives our proactive design specifications then. So we may have design in process. Now I have a way that I can affect that design that's intelligent, is based on the threats that I'm going to see, but takes into account some of the things that have already been done in the work done by our development team. So I'm going to talk to you a little bit about the methodology, and this is, okay, literally how are we going to go about this threat modeling? So I've thrown a lot of ethereal stuff at you. This all sounds really well and good, but what are we really doing? So when we come down to a threat model, this is not dissimilar from what you would see if you go out and read a book on threat modeling, one popular one I've talked about a few times. The first part of this really is just to capture what is that design. Now, depending on your development shop, what type of methodology they follow, maybe they've got some type of design work done for you. Maybe this is something you're going to create. But the best way to do this is simply, and this is something that is a common theme throughout threat modeling, is to get together these whiteboarding workshops where you can sit down with the stakeholders and walk through that design. Understand what the design looks like, and then start to document the data flows. So if I understand what data is in there, I understand how it flows through the system. Doing this as a collaborative session is very important. What you start to see as you do this and you're working through, as I said, you've got developers or you've got systems architects and application architects who are building this. They start to ask you questions as a security engineer. Hey, I'm thinking of doing this. What do you think of this idea? Or what do I need to be careful of if I do that? And so more so than even just your threat model, now you've started to build this collaboration between your security people and your development teams. Your project teams now have that open line of communication. And this is a vast value add to this process. This is the type of thing that now you can start to establish real returns from the activity that you're doing that extend beyond just, hey, we're going to do this threat model, this application. So what does this look like? We've captured the design. We've captured the data flows. It ends up looking something like this. Now, what you see when you get into threat modeling, everybody's got their own different ways that they like to capture this stuff. Certainly, there's threat modeling tools out there that draw their own diagrams in certain ways. Everybody's got their own methodology. This just happens to be the one that I use at Aspect. Okay, so what you see here, the key parts, though, that you'll notice that go beyond your typical threat modeling data flow diagram is that we've got actual components of the application represented here. You can see things like load balancers and web proxies, so things at an architecture level that are being represented. We've got different constructs within the application itself. You see web servers and other things. Those are all things that kind of get lost if we do threat modeling too early. If we don't have that design context, those are things that we lose. You see up here as well, specifications as far as the different communication paths. You see we've got SQL and HTTPS and all the different protocols labeled and so forth. Capturing these, again, that's context that oftentimes maybe we define as part of the threat model, but isn't there if we're doing the threat model before any design work's been done. Everything we do through the rest of the threat model is based on what we see here. So this is why it's important to get this right. This is why a collaborative session where we're doing things on a whiteboard and working with developers who can immediately see how we're understanding what they're telling us and can correct what we're making mistakes on. We may even have the architects help us draw those types of things. They may put their own spin in there. This becomes a valuable piece, not only for the threat modeling that we're doing, but obviously this type of documentation for any system. A lot of us don't have this typically in our projects today. So now we've got something that's additional value down the road for that particular application. So now we've got the data flows. The next thing we want to do is talk about where are the controls that are already planned. What are they intending to implement? What type of authentication? What type of authorization? What type of logging features are they looking at? All of the different security controls that you can think of, break those down into categories and start to represent those in our diagram. What are they doing to protect us against things like cross-site scripting? So do they have controls for input validation and output encoding? Things of that nature. Once we have that general idea, now we can start to look at threats. Now let's look at who are those threat actors? What are the things that they're going to look to do to our system? What's the data they're going to be after? Where are they going to attempt to take over a system or potentially denial of service? Boy, that came out really well, huh? To attempt to deny service, okay? So this is where we start to think about how have you guys heard of Stride before? Does Stride ring a bell to hopefully a Couple, 1, 2, 3. All right. So when we talk about STRIDE, we're talking about just categories of attacks, right? We've got spoofing and tampering and repudiation and so forth. This is now where we start to draw that in. And so what you can see here is just one way that you could potentially represent it. The way we do it here is you've got a number of different threat actors represented and the relative risk rankings in terms of likelihood, impact, and overall risk of each of those threats. So we start to identify those. We show the attack paths, which are denoted there with red. So this is the type of thing that we're looking to understand at this point. Now we start to see, okay, here, based on how the system is architected and the technologies that are at play, now we have a better understanding of where are they attacking us, how are they attacking us. So where do I either need to validate that the controls we have designed are sufficient, or where are we potentially missing controls that need to be added to this environment? So then, as you can imagine, the last piece is that controls analysis. So now that we understand who our threats are, where they come from, they may be internal, they may be external. We understand the different types of attacks we may see. We understand where those attacks are targeted. Now we need to understand the controls that we have in place. The controls here are represented by triangles. Again, your mileage may vary. Whatever works for you is fine, but what we're trying to represent here is the relative strength of those controls and their location within the system, so that now we can visualize how those address the attacks and those threats that we identified earlier. In this case, the colors are important. Colors aren't always the greatest thing, I will say. I think it's something like 25% of the population is colorblind, so you may not want to use colors to represent it, but in this case, blue are strong, green are sufficient, and so on and so forth. There's no red up there, but if I had any controls that were outright missing, those would be represented in red. Again, I put this up here not to brag that this is like some great wonderful thing that we do so well, but more to spur ideas for you on ways that you can represent this. Again, you'll find if you search the happy interwebs, you'll find plenty of information, different ideas on how to draw up diagrams similar to this, but hopefully this provides some context for you in what I'm talking about. So, I said I was going to talk to you about this concept of ensuring that all is not lost. If we look at traditional threat modeling, we have that ideal, hey, we're going to put this early in the life cycle. We already discussed why that doesn't happen. If I go out and I look at, say, different organizations who offer threat modeling services, you'll see many of them sell threat modeling just like the way they would sell a pen test or anything else. It's this one time I come in, I do an assessment, boom, here's your threat model, I hand you a report. The key to threat modeling is ensuring that we get more out of it than just, hey, you need to change your design of your application this one time and make this one design better in these following ways, right? We get that from pen tests all the time, right? We do a pen test against my application, I'm going to spit out a report. It's got a bunch of, hey, you've got this vulnerability, this vulnerability, this vulnerability, fix it this way, this way, this way. That's great. It's really prescriptive. It gives me some actionable stuff. But then it goes away, and once I start making changes to my system, that pen test is no longer valid, and it means very little going forward for pen tests I may conduct in the future. So what we want to do with threat modeling is we don't want it to sit out on an island like this. Threat modeling is not something that becomes a one-time activity we just do and it's done. As I said before, as security experts, we want to drive more value. We want our management to be able to understand why this is so effective and what it's going to mean from a larger sense. I'll use one of those cliche terms. We want it to look holistic. I shudder at the word, but because it gets overused far too often. But the fact of the matter is we want something that's going to impact our entire application security program, not just be this one-time event. So we're going to look at ways that threat modeling helps us affect change in the SDLC. There is a loop of feedback between the threat model and the SDLC. The obvious is the threat model providing that design information, things that we need to change about this particular app that we just threat modeled. But we'll see some more strategic ways that we can use threat modeling to better our overall software development. We can also use threat modeling to drive better security testing. whether those be application pen tests, vulnerability scans, code reviews, whatever it is that we're doing today from a security activity perspective, we can use threat modeling to give us a better overall coverage and rigor within those activities. And then, as we kind of mentioned, and as the title of this talk suggests, how do we plan our security going forward? So the last part of this, we're going to look at how can I use threat modeling to help me build an overall risk picture of all my applications, so I understand not only what applications are higher risk for me, but maybe what types of threats are common, what types of data are common, where does that data exist, which divisions of my organization, and so forth. So let's start by looking at how we feed the SDLC. So the SDLC ties into threat modeling. As we said, we're going to look at initially how do we tie this in from the design phase onward. And we're going to go out, we're going to do this threat model, we're going to get all this wonderful information, but what do we do with that information really? I mentioned before that we're looking for design patterns, right? So as I'm going through and I start to implement a threat modeling program within my organization, one of the things we're going to start to see pretty quickly is that there are common design patterns across our applications. Some of you may already be aware of some of these today. You might have specific implementation guidance that pertains to certain design patterns. This enables you to expand on that or create it if you don't have it today. So as we start to see these different design patterns, now we can start to identify them, document them, and provide reference architectures and implementation guidance to our development teams for how they execute these design patterns. If you're going to deploy, say, an application into Azure, what type of authentication do we require as an organization? Maybe we tie these back to best practices, but we want them tailored to what is important to us. If you read through the abstract on this talk, one of the key things, what's secure for one company is another company's disaster, right? Depending on our needs, depending on our risk posture, depending on our risk tolerance, this can vary. So we want these design guidance to fit what makes sense for our organization. Now the feedback from that, on the flip side, is the SDLC can now provide us information back into the threat modeling methodology, specifically emerging technologies. As I said before, we've probably all experienced this at some point. You get out there and you know that technology is changing, new technologies, our developers are going to want to use it all the time. Maybe we're in an organization that has never seen Node.js before, and suddenly that's what everybody wants to use because it's new and sexy. It's not so new and sexy anymore, but it was a couple years ago. Those are things that now the SDLC starts feeding back into threat modeling that now we can consider as a part of our threat models going forward. Additionally, yes, we're going to provide this great design guidance and some of this, these recommendations as part of our different threat modeling activities. But developers are pretty cool, right? They'll see something, a lot of times they know a way to do it better. Or they may come up with something that we hadn't thought of from a security perspective that addresses it in a different way that maybe we like a lot better. So now from the SDLC, we can start to drive those improved design patterns back into the threat model so that our future threat models take into account the lessons learned from previous cycles of software development. When we look at security testing, so let's assume for a moment that we've got our threat modeling program in place and we're doing this. We've also got a pretty robust program for doing our code reviews, doing our application pen tests, and so forth. Threat modeling can help us refine that and actually drive some efficiency there. Through threat modeling, one of the things we can do is very easily identify test cases. So we're gaining quite a bit of business context into that application. We're gaining quite a bit of technical context into the design of that application. As we document these things, these can start to drive very targeted test cases when it comes time to do a penetration test. We're talking about those specific controls that we implemented within this application. That's great information when we get ready to start doing a code review. Where do we want to direct our efforts in a code review? Yeah, maybe we're running some cool automated tool to do a lot of that static analysis, but maybe we put a little extra manual time to look at that single sign-on that they implemented, or that, funky authorization construct that they decided to use. So in the end, threat modeling gives us that ability to now refine the security testing and to ultimately make that not only more effective, but more efficient as well. On the flip side, coming back, security testing certainly will potentially identify new threat vectors for us. Maybe a new technology has been used, and something that we didn't consider when we went through the threat model gets identified through security testing. Now we have a lesson to be learned, right? We can take that, put that back into the threat model. Future applications that use a similar design pattern now can learn from the lessons that were taught in that previous design. Additionally, we can improve that implementation guidance. Again, I said before, developers are really cool people. They're really smart. They come up with a lot of neat ideas that security people didn't even think of. I've been there more than once in a threat model where you sit down and a developer throws something in front of you and it's like, you know what? I never would have thought to do that. That's pretty darn cool. So we can use those as well. This is a great way that now we've enabled information sharing from maybe completely separate development divisions within our organization. And now we're able to leverage that combined knowledge and that combined expertise in new ways that, hey, you know what? We didn't have that before because maybe those developers aren't talking. Maybe that information didn't get shared before. Now there's a conduit for that. And then finally, this concept of security prioritization. So many of us at least, myself included, have been in those organizations where we have an overwhelming amount of systems and applications and such that we need to make sure are secure. We have no idea how this all ties together. We may not know where the hotspots are. Sometimes we have a general idea just through tacit knowledge. We know that, hey, this application over here pretty much stinks. It's a steaming pile. We know that these guys over here do something really good. But what if we could provide a clearer picture to management on where the problem areas lie, where certain divisions have more risk to worry about, or more vulnerabilities and more threats to worry about than maybe other divisions. Now you've got a way to justify the money you want to spend. When you go and you say, we need this in our application security program, and their first question is why? Now you have the answers. So one of the things we drive out of threat modeling, or we can drive out of threat modeling, is this idea of an application risk rating. And in literally 10 minutes, a couple easy questions that you would ask in a threat model anyway, you can start to establish a risk rating for these applications that now leverages the information that you're gaining through your threat model. It's transformable so that you can provide it to decision makers to look at any different way from Sunday, whether they want to see it by divisions or by operating systems or by PCI data or whatever your concerns are. There are ways to meld that. The feedback then from that is that your security planning can refine your methodologies, whether it's in threat modeling, security testing, or otherwise, based on those risk levels. Maybe we've got low-risk applications. We say, you know what? We're not going to pay some consultant $60,000 to come in and do a 2-week dynamic analysis and code analysis on this application. It's low risk. Maybe we have some automated tools that instead we can enable our developers or security architects to run and provide a certain level of assurance for those low-risk applications that's a little less than what we want to do for our high-risk applications that, oh yeah, by the way, are the crown jewels of the organization and need that extra attention. So what I'm going to show you now is a tool, And I'm showing you this because I promised you, if you read through the abstract, that this is what I was going to do, was show you a tool. This isn't meant to be something that, hey, here, go use this, run it. This is, again, meant to be an example of something you can do. What you're going to see is something that is built in Microsoft Excel. Now, it's in Excel because Excel is easy, it's portable, and everybody has it. Ideally, you'd like to see this be in some type of database or some other robust system, maybe a web application, something of that nature. But to show you how quickly and easily you can get something like this spun up, I'm going to show you this in Microsoft Excel. So we're going to hope and pray that the monitor still reacts the way it did before, because this is Windows 10 and God only knows. Okay, so what you have in front of you here is what I fondly refer to as the ASRL, or the Application Security Risk Level. This is a tool, as I said, built in Excel that allows me to capture information about an application that I would be capturing anyway during a threat model. The difference here is that I'm capturing this information and it pertains to risk as much as architecture, as much as security. And by capturing this information, I'm able to define a scoring model behind the scenes that then develops for me a risk level. Now, I break this down into 5 risk levels. Again, your mileage may vary. Maybe you want to establish more, maybe you want to establish fewer. That's entirely up to you. But what you'll see here is that there's 5 risk levels. And what we use this for is now I can go out and I can do that prioritization. I can say, hey, you know what? Here, let's break this down into applications that within a specific division. I can see this division's got a lot of high-risk applications. This division's got a lot of low-risk applications. Now I know where I need to spend my attention from a security perspective. So before I get too far into this questionnaire, I'm going to show you just really quickly the way that this is all driven. And I mean, this is actually kind of cool and usable. So I've got a section here where I can define my business lines, which then gets pulled in later. I can define business systems. So when I talk about business systems, I'm talking about high level. This might include multiple software systems, multiple applications, multiple groups of people. So you see things here like vendor payments, and you see sales leads and accounts payable and so forth. These are, business systems, things defined at a business level. The heart of this is really the application inventory. So here's all the applications that I know I've got within this organization that fit into those business systems that are within those business lines. And as you can see, this is all tying together. Each of these, in this case, this is kind of a cool little Excel. All these are tied together. These are drop downs that are generated. If I select a business system here, if I put in, say, a new application, we'll say the marketing portal. I can almost type. And then, through selection, it'll assign the other pieces. Not terribly important. Again, this is just to give you some ideas of what you could do with this. And in this case, I say it's software-based. So now from here, if I resort the applications, that generates my happy macros. Yes, we're using macros in Excel. Dangerous, scary stuff, but I trust it because I wrote it. Or, well, someone within my organization wrote it. I won't claim responsibility for it. So in any event, now I've got this new application and I want to complete this ASRL. And that freaked out on me. That's okay. We'll use the one that's here. So we look at this application and you can see it's got things in here, basic stuff about when it was profiled and so forth. But right away we jump into starting to understand the risk. What's the classification of information being processed, stored, or transmitted? How large is the user population? What's the application's primary architecture type? Things like that. So we capture all these, we've broken them down, and as you can see, they're actually all, in this case, again, to make it scoreable and very automated, they're just simple drop-down lists. And what that ends up giving me is then this profile report, where I've got some basic transformations. You could expand this, and certainly we typically would. You can see that I can break it down by specific business lines. I can then go even into divisions and specific business systems and start to get a view of what's out there within my organization. If you ask any CISO, go out there and hand them something like this and say, I can tell you across the organization where your highest risks are from an application perspective, from a security perspective. This is a CISO's dream. So again, really simple tool here. Implementing something like this of your own is a great way to leverage what we're doing in threat modeling to really enable us to take it to the next level and start to build that prioritization. Like I said before, from here now you can see I've got ASRL 5, which is our highest risk, all the way down to ASRL 3. Now I can start attaching different levels of application security rigor, different activities I'm going to perform based on the risk level of these applications. So with that, I'm going to wrap things up because we are getting down to the end of time. I just want to make sure that I left a few minutes here for any questions, if there are any, from the group. So yes. Have I published a template anywhere? For which? The diagrams or the tool? The spreadsheet? No, not at this point. Like I said, it's kind of more, it's one idea. It is probably something I can share with you though, if you want. Actually, let me go back to the top. I'll put my email back up there, so you guys can contact me. I'll see too if there's a good way to share it. Cause yeah, I mean, it would definitely be helpful, something you can build off of. So that's a good question. Any other questions? Okay. All right. Well, you guys continue to have a great con. Hopefully you all win something in the drawings tonight. Appreciate the beer, sir. You are awesome, as always. Hopefully we'll see you next year. And you all take care. We'll see you on down the road.